again, this is module number 7, solids of revolution. So we'll need to determine the volume of a particular curve as it revolves on a specific axis. Again, by definition, solids of revolution is formed when an area is revolved in about a fixed line, or basically called your fixed axis of rotation. There are three methods that we need to apply in this particular topic. Those are first one, the this method. By considering this method, we need now to consider that particular curve to be revolving in a sense that it is a particular disk, or a disk with respect to an unknown thickness. So, parang consider natin siyang isang this with multiple thickness or multiple elements of thickness, which will then be identified by a volume will then be identified by the differential volume equal now to pi r raised to 2 times the thickness. Thickness is basically the differential thickness of the curve with respect to a fixed axis of revolution. Then same goes with a ring and washer method. By the name itself, we need to consider two radius, ring and washer, with respect to an unknown differential thickness t. Again, by this, the volume of a curve revolving on a fixed axis, this is now the differential volume of a curve, is simply equal now to pi times radius or outer radius squared minus the inner radius squared times the thickness. And again, differential volume is the volume at which this particular curve revolve on a fixed axis. Then T is your differential thickness based on the curve bounded by this volume. Then cylindrical shell method. Again, we need to consider this particular curve as a cylindrical shell. So parang pinakapal lang siya na washer. But with cylindrical shell, meron tayong specific height or specific length of this cylinder. Then again, this is now the differential volume is equal now to 2 pi times the radius 1 and radius 2. So meaning, dalawang volume yung masosolve natin. Radius 1 with respect to the inner radius and radius 2 with respect to the outer radius. Bakit hindi pwedeng radius outer minus radius inner? Magkaiba yung magiging volume natin when it comes to cylindrical shell method. Then mag-iiba rin kasi yung height. Okay? Then the thickness of this cylinder. Okay? Ang cylinder usually used with respect to horizontal element, while washer at saka this method under naman yan ng vertical elements. So apply natin ulit yung ating area bounded using vertical and horizontal element, but will no longer apply up, bottom, left, right element type. But with this, we need to identify the radius equation with respect to the thickness of the curve, which the curve will revolve. So for our first example, find the volume generated by revolving the area bounded by the curve equal to e raised to negative x. So if it is an exponential function curve, anong mangyayari? At some point, this particular curve will not turn up equal to 0. So, but it will have an equivalent value at some axis. But we'll need to determine that later. The axis in the line, as it intersects line x equal to 2, then revolves about x-axis. So, sa pinakamadaling part ng problem na yan, alam na natin kung saan natin i-revolve or hahanapin yung volume at which this particular solid will revolve. So, at which axis daw? Fixed axis, sabi ni solids of revolution. Based on the problem, it will revolve eventually directly at x-axis. Walang pakialam kung clockwise or counterclockwise yan, ha? So, revolves at x axis. So directly at x-axis, so basically at x equal to 0. But how are we going to plot our curve, which is y equal now to e raised to negative x? Let us consider a multiple points, x and y. So at x equal to 0, what is the value of y? Plot na natin yung ating tawag na dito, x line. So this is 2, which is your x equal to 2. So at x equal to 0, ano yung value ng ating y? E raised to 0. That is e raised to 0, which is basically 1. Tama? So dito yung ating first point. But the rest of this, let's just say x is equal to 1 at e raised to negative 1, that is 0 point something, 37, x raised to 2 at e raised to negative 2, that is 0.14, e raised to negative 3, that is 0.04 or 0.5, and so forth and so long. Okay, this particular curve eventually is this is now an exponential function. Remember, if it is exponential function, this is now a curve that will never touch x-axis or never touch the origin of an axis. Okay? So most likely, magiging ganyan yung ating curve. And dire-diretso yan hanggang 0.000000001 and so forth and so long. Okay? So this is now our curve. Our curve is simply identified as y equal to e raised to negative x. Again, so ito na yung ating exponential curve. Okay? So for the first equation, let us try to solve the volume at which this particular curve revolves at x-axis. Considering first method, ano yung first method na pwede natin gamitin? Yung pinakamadali muna. Let us try solving this problem using this method. So using this method, we need to identify the radius at which this particular curve will revolves at x-axis. Then, the thickness. Yung thickness, differential thickness yan. Ibig sabihin, we need to consider a specific element within the span of the curve from point of origin 0 to x equal to 2. So, kayong bahala. But with this method, ang pinakamadaling gamitin dito na element is basically your vertical element. Anywhere naman yan. So with vertical element, meron na tayong identified unknown thickness of the disc, which will then revolve along x-axis. So this is your T thickness with respect to x-axis, that is dx. Okay? Ngayon, gawa tayo ng imaginary disc. A disc that will revolve along x-axis. Project natin yan. Project natin yan. That is there. So that is already half of the disc. So ito yung ating disc. Okay, that is our disc, which have a differential thickness dx here. Okay. Then Ano yung kailangan natin na isa? The radius r. Okay? Ano ngayon yung value ng ating radius? Our radius is with respect to the vertical element. So, vertical element, basically, R is simply equal to Y. Hindi naman natin alam kung gaano kataas yung element na yan or anong point yan at an exponential curve. So, that is simply R is equal to Y. Then, imagine that this curve will revolve along x-axis. So, Y positive and Y negative. So, basically, iikot lang naman yan along x-axis at point O. With that, alam na natin yung radius, alam na natin yung thickness. Ang kukunin na lang natin will be our lower and upper limit. Remember that this method is basically the differential volume is equal to pi radius squared times t. Okay? Ayun yun, this method. Differential volume at which the curve revolve at a fixed axis, which is x-axis. This is now v equal now to the lower limit x1 and x2 of radius squared. Pi is constant, labas lang natin yan. Then thickness is simply dx. Okay? So if radius is simply equal to y or an unknown vertical distance height y, such that we know y is simply equal to e raised to negative x, di ba? It is y squared dx. First, ano yung ating upper and lower limit? Vertical element. Ano yung volume na kinoconsider natin? Sabi niya, the axis and the line x equal to 2. Volume generated by revolving the area bounded by the curve equal to y equal to e raised to negative x and the axis and the line equal to x to 2. So, itong section na to yung kailangan nating makuha ang volume. So, from what point? Yung volume natin. That is from point 0 to x line equal to 2. So, that will be our limits. Lower limit is simply equal to 0 and the upper limit is now mababasa pa po ba?
Yes, sir.
And upper limit is now equal to. Then y, we know y is simply equal to e raised to negative x, then square dx. Simplify that. That is simply 0 to e raised to negative x, then negative x times 2, that is what? Negative 2x dx. Okay? Then, again, basic application of your integral calculus with exponential function, that is simply negative 1/2 of pi e raised to negative 2x plus c, then your upper and lower limit. So the volume at which this exponential curve revolves exactly at x-axis, that is now equal to negative 1/2 pi e raised to negative 2 times 2 minus or negative 1/2 pi e raised to negative 2 times 0. Okay? So on your own, try to solve that. That is 1. 2 times 0 is 0. E raised to 0 is 1. Tama? So that is pi, negative pi over 2. And the volume now is simply equal to negative 4 and negative pi over 2 of e raised to negative 4 plus negative 1/2 pi times negative is simply positive 1/2 pi. Labas lang natin si 1/2 pi or pi over 2. Then we'll get 1 minus e raised to negative 4. Anong unit natin? Cubic units. So the volume at which this exponential curve revolves at x-axis starting from 0 to x equal to 2 using this method should be now equal to pi over 2 times 1 minus e raised to negative 4 cubic units. Again, don't forget yung cubic units. Huwag i-decimal yung answer. Okay? So, final answer, pi half times 1 minus e raised to negative 4 cubic units. Cubic units. So, using this method. So, if we're then going to use cylindrical method, dapat parehas yung volume na lalabas, ha? But mag-iiba yan when it comes to ring and washer. With ring and washer, meron tayong vertical and horizontal limits dyan. Hindi siya pwede sa iisang axis lang. Okay? This at saka cylindrical, more or less, considers a specific axis at which it will revolves. Pag si washer or ring method, meron tayong dalawang axis in concern. Okay?